You are using the Outbox pattern and wondering how you can scale it. In this video, I'll show you how you can scale the Outbox processing to handle billions of messages per day. This video will be completely focused on scaling the Outbox processing. We're going to start from an existing and functional Outbox processor component, and we're going to measure how many messages we can process in 1 minute. And then we're going to see how we can scale this one step at a time, and I'm going to demonstrate a few techniques that you can apply to your Outbox processor to make it faster. So let me walk you through the existing Outbox processor implementation. We're going to just fetch messages from an Outbox messages table that we already have in the database, and then we're going to deserialize each message, publish it using mass transit to a RabbitMQ instance, and update the message in our database to mark it as processed. If we get any exception, we're going to record this exception for each of the Outbox messages, and we won't be processing it anymore. So this is the simplest possible and the least performant implementation of the Outbox processor component. We're going to run this from our background service, which is the Outbox background service, and right now the Outbox processor frequency is 5, which means we're going to run this every 5 seconds. However, I created an additional cancellation token source with a delay of 1 minute, after which we're going to trigger the cancellation, and this is because I want to run this as a sort of a benchmark. We're going to start the application, run the Outbox processor for exactly 1 minute, and then record how many messages we were able to process. So we are going to first establish the baseline for our implementation, and then we're going to see how we can optimize this to scale the Outbox processor. Inside of the while loop, I'm going to count how many iterations I did. I have some logging delegates for performant logging because I don't want this to impact our performance too much. And essentially, I'm just going to create a scope, and inside of the scope resolve the Outbox processor. I'm going to do this just once, although we could do it inside of each iteration of the while loop, because this is going to be slightly more performant. Inside of the while loop, we're just going to call the execute method on the Outbox processor and count how many messages we were able to process. Then we're going to delay this for a given period and then process the Outbox table again. I also have a database initializer class that's going to set up my database if it doesn't exist, initialize the database tables, which is just the Outbox messages table, and then seed some initial data so that we have what to process. So let me walk you through the initialization step, where I'm creating an Outbox messages table, and this just matches the structure of the Outbox message class. So we have a type content, which is our message serialized as JSON, when it occurred, and when we processed it, and if we encountered an error. So this is what we have in the initialize database method. And then inside of seed initial data, I'm going to truncate the Outbox messages table and then insert 2 million Outbox messages by serializing the order created integration event. I'm using the copy command from Postgres to make this insert more efficient so that this completes in a relatively low amount of time. So now every time I start the application, I'm going to have a fresh batch of 2 million Outbox messages that I want to process. And lastly, inside of the program file, I'm just setting up a connection to my database. I'm also setting up the connection to RabbitMQ with mass transit, adding my background service, initializing the database using the database initializer, and then finally starting the worker service. So this is our base setup. Now let's go ahead and run this. And when I mean this, we're going to run the Outbox processor. And for this initial run, I'm going to omit the delay here so that we are running the Outbox processor as fast as possible. So I'm going to start this and I'm going to run it in release mode. And you will see that we are first inserting the Outbox messages into our database, and then our Outbox processor is going to start. So I'm going to jump forward 1 minute, and we're going to see how many messages we were able to process. So after 1 minute, we were able to process almost 7,000 messages, which isn't all that much. Now let's go ahead and update the Outbox processor and increase the batch size. And this is actually one of the first things that you could do when optimizing the performance. So now instead of processing 10 messages at a time, we're going to process 1,000. So let's go ahead and run our benchmark, and I'll fast forward to the results. And just just by updating the batch size to 1000 messages, we are suddenly able to process 74,000 messages in 1 minute, which is slightly more than 1000 messages per second. So this is more than a 10x increase by just increasing the batch size. And this is one of the first things that you should consider when you want to scale your Outbox processor. Now, in order to take this further, we need to have some more fine-grained measuring of the individual steps inside of our Outbox so that we can figure out where the bottlenecks are and what we want to optimize. And I'm going to do this in a very simple way. I'm just going to create a set of stopwatches. So let's create a total stopwatch, and I'm going to start this right away. So I'm going to say stopwatch start new, and then I'm going to create a step stopwatch, which I'm just going to initialize without starting it right away. So the total stopwatch is going to measure the total execution time of one iteration of the Outbox processor. The step stopwatch is going to measure the individual steps. So we're going to start the step stopwatch right before the individual steps, and one of the first steps that I want to measure is the query time to fetch the Outbox messages. So we're going to get the elapsed milliseconds right here after we complete the query, and then I'm going to restart the stopwatch when I go into my for each loop, and this is where I'm processing the individual messages. So let's say right after the loop I'm going to grab the elapsed milliseconds, so step stopwatch elapsed milliseconds, and we're going to grab the update time. After completing the transaction, I'm going to stop the total stopwatch, and we're going to grab the total time from the total stopwatch elapsed milliseconds, and I have a predefined logger in the Outbox loggers where I'm going to log the processing performance. So I need to pass in an iLogger instance that I don't currently have. So let's go ahead and inject this. So I'm going to specify an iLogger of the Outbox processor, and then I can specify this as the argument here, and then I'm going to pass in the total time, the query time. I don't have the publish time and the update time separately just yet. So let's go ahead and pass both of the values at the same time, and we're going to fix this right now. So what I want to do is separate the publishing of these messages to the RabbitMQ instance from the updating of these messages inside of our database. Now, for the initial implementation, I'm just going to do a copy and paste and remove the duplicate parts. So this is going to be our publish step, and if this is confusing, it's going to make more sense in just a moment. So what I want to do here is just deserialize the message and publish it to RabbitMQ without updating my messages in the database. And then in the second loop, going through the Outbox messages, I want to omit the publishing step, and we're going to update the values in the database. Now, this might be confusing because this exception here won't be the correct exception. We're going to fix this in just a moment, but I just wanted to split these values so that we can measure them separately. And this is also part of the next optimization that I want to run. So now I'm going to log the publish time and the update time separately. And let me go back to the Outbox background service, and let's run this every few seconds. This is going to produce a smaller number of individual logs so that we can actually take a look at what is going on. So let me start the application, and then let's take a look at the logs from the individual processing step. So you can see that our Outbox processor is running, and I can take a look at the individual times for processing the Outbox. So you can see that the time it takes to read a batch of messages is around 70 milliseconds, which is pretty fast. The publish time, which is how long it takes us to publish one batch of 1000 messages using mass transit, is around 370 milliseconds per iteration. And then to update this batch of messages one by one to our database, which isn't efficient at all, is around 300 milliseconds. So now we have something to work from. So let's tackle this one step at a time and optimize each of these individual steps. So let me close this down, and let's go back to the Outbox processor. The first thing I want to focus on is this part here, where we are selecting the Outbox messages that we want to process. So instead of using the select star, we're going to select only the columns that we need in the database. And if you check out the usage of the Outbox message here, you can see that we are using the message type, the message content, and down here in the update, we're using the message ID. So we have something to work from. So let's go ahead and select the ID as the ID, and I'm just casting this to the respective column names. Then I need the type as the type and the content as the content property. So this query should work. So let's go ahead and actually analyze this query to see what the execution plan is like. If I jump into the Beaver for a moment and I paste in my SQL query and I run the explain execution plan command, we're going to see what the execution plan looks like. And you can see that we are doing a sequential scan on the Outbox messages table, followed by sorting this table on the occurred on column, and finally limiting the number of rows that we want to return from the database. So how can we make this query more efficient? What if we introduced an index on the occurred on column and the processed on column, and we also included the columns that we are reading inside of our query? Such an index could look something like this. I'm going to call it the Outbox messages unprocessed, and we're going to apply this index on the occurred on column so that we sort it in ascending order, which is exactly how we are sorting in the select statement here. And then I'm also indexing on the process column only so that I can add a filter on this column and index only the rows where the processed on column is null. And these are the unprocessed messages. And the reason I'm including the ID, type, and content to be part of this index is to make this a covered index. So in this case, the query above with the index in place. So let me create the index. This could take a few moments because we have a lot of records in the database. And now let's go ahead and rerun the execution plan for my initial query. And you can see how this significantly changes. So now what we have is an index only scan. We are able to utilize this index properly to satisfy the query that I have here, and I'm only able to return the 1000 rows that I want to fetch in the current batch. So this is called a covered index, and it's something that you can use to optimize your Outbox processing. So let's go back to our code, and I already have this statement prepared in the create database SQL command, and let's just add this to the database initializer. So right here, after creating the Outbox messages table, I'm also going to create my index if it doesn't exist. So now I can go back to the Outbox processor, and let's just run this with the covered index in place and see if we are getting a performance improvement. So I started the Outbox processor, and we're going to insert a few million records into the Outbox messages table, and then we're going to start processing the Outbox in batches. And right away, you can see that the query time after the initial iteration falls down to 2 milliseconds or 4 milliseconds in this case. And if you recall, it was initially around 70 milliseconds. So this is a significant performance improvement from just making the query more focused to fetch only the columns that we need and also adding a respective index inside of our database. So this is definitely a step in the right direction. I'm going to stop this now, and then let's move on to the next step. And this is publishing our messages to RabbitMQ. So there are a few things you can do here. For example, we are consistently fetching the type from the messaging assembly based on the type name. This uses reflection, which is inherently slow, so we can optimize this by simply caching the results for a given type name. So for example, I can create a private static read-only concurrent dictionary, and the key is going to be a string representing the type name, and we're going to return the type as the value. And let's call this the type cache. And then I'm going to create a helper method. Let's make it a private static method returning a type, and let's call it get or add message type. We're going to accept a type name as the argument, and we're going to return type cache. I'm going to call the get or add method, specify the type name, and then we need to provide a factory to create a type if it doesn't already exist. And we're already doing that here, so I can just copy this and paste it here. And instead of the message type, I'm going to specify the name. And we can complete this method, and now I can call it inside of my loop. So right here, I can call get or add message type. Now, the next problem that we need to solve is how we are actually going to update the Outbox messages if the publish fails or succeeds. So let's go ahead and create a struct that I'm going to call the Outbox update, and I'm going to add just a few properties inside. So an identifier for my Outbox message, a date time property for when it was processed, and an optional nullable string property representing my error. And then how I can use this is right before I start publishing my messages, I can go ahead and create an update queue. This is going to be a new concurrent queue because the optimization that I want to make is publishing the messages in a batch or in parallel. So the argument here is going to be an Outbox update. And what I'm going to do is after I successfully publish a message, I'm going to enqueue a new value. So let's create an Outbox update instance. And I'm going to set the ID based on the message ID of the current Outbox message. And the processed on column is going to be date time UTC now. Now, if I get an exception, then I'm going to also add an Outbox update, but I'm going to include the exception details. So I'm also going to set the error to exception to string. And this is going to mimic the behavior that we previously had with the one difference. Here, I'm going to iterate over the update queue, which already contains the same properties that I need to update my Outbox messages. So I have the ID and the processed on time that I can pass in from my message. And let's actually specify them in the correct order. And we can also specify the error as another argument. Now, if I want to omit passing in all of the individual values, I can just pass in the Outbox update itself. And note that I should also take care of updating the error, which is either going to be set to null or a concrete value. So now I can completely omit the try-catch statement here and update this into something like this. So now our update step is much simpler, and we're also taking care of logging the correct value if we successfully updated this or we got an exception. And now let's focus on how we can publish our messages in parallel. So I'm going to extract this into its own method that I will call publish message. I'm going to move the cancellation token as the third argument, and then let's extract this into its own message. Now I also want to make it static, so let's add the publish endpoint as another argument, and then here where the publish message is, let's make it static. And because we can't access the publish endpoint, we're going to accept it as an argument. So I'll specify the publish endpoint here, and then this should compile. So we're looking good here. And then what does this allow me to do? I can go ahead and replace this for each loop with something like this. Let me comment this out. And I can go ahead and say publish tasks and use the messages list. And I want to select each message and pass in the publish message static method where I can pass in the message, the update queue, the publish endpoint, and the cancellation token. Then I can materialize this into a list so that I can finally say await task when all and pass in the publish tasks. And if you're wondering what the motivation behind this is, there's actually a publish batch API on the publish endpoint, and you can use this to publish a batch of messages. Now, what this does inside is exactly what I'm doing here. It runs task when all, and it selects a collection of publish tasks. So this should be a nice optimization that we can add to the current implementation, and let's see if it helps or not. So I'm going to run the Outbox processor again, and we're going to start by inserting the Outbox messages that we are going to process. And then we're going to start iterating through the Outbox processor. And we want to observe if there is a noticeable difference in the publish time. So let's wait for our iterations to stabilize. And you can see that the publish time hasn't changed significantly. However, publishing the messages in a batch is still more efficient, so I'm going to continue using it. Now, one caveat of why this didn't yield a noticeable performance improvement is because we are waiting to get back an acknowledgement from RabbitMQ that a message was published successfully. This is done to make our publish more reliable, and I don't want to turn this off, but this is one of the reasons why our performance didn't change much. So now this next part is going to be somewhat interesting, and I want to optimize how we are updating the batch of messages from the update queue. Now, the piece of code that I'm going to write is going to be a bit cumbersome, so I'm just going to paste the code in, and then let's explain what is going on here. So we are checking if we have any values in the update queue, and I'm defining a variable that represents the SQL query that I want to execute on the database. This is an update statement on the Outbox messages table where I'm setting the processed on column and the error column on the Outbox messages table. Now the trick is how we are selecting the values that we want to update. I'm using from values and then a placeholder for the actual rows that are going to represent our update operation. And what's happening here is we will select each tuple from the values inside of this statement here as an ID, processed on, and an error column. We're going to match the identifier of the value with the identifier of the Outbox message, and if they match, we're going to apply the appropriate update. Now, what is the idea here? Well, we want to create a batch update SQL statement that I can send to the database in one round trip and execute all of the updates in the database. This will be much more efficient than what we were previously doing, and that is updating one value at a time. Now, the placeholder here is where I'm actually supposed to specify all of the parameters that I'm going to pass into the query. And I'm going to use the dynamic parameters type from Dapper to create a set of dynamic parameters. The values are going to be ID, processed on, and error, and we're going to append an index so we can differentiate them for each of our update queue elements. And of course, we're going to pass in the actual value. So this is going to be our GUID as the identifier, the processed on column, and the error. Then we're going to run string format and execute this on our database in one round trip. So let me place a breakpoint here, update this to debug, and then let's start the Outbox processor. And in a few moments after I initialize my Outbox messages, we're going to hit this breakpoint, and I want to show you what's going to happen. So we land on this breakpoint, and if I check the update queue, you can see I have 1000 elements inside. This is our one batch of Outbox messages. Now let's take a look at the values list that I'm going to generate here. If I open this up, it's going to be a very large string containing the tuples that represent my individual parameters. But each tuple is just an ID of the Outbox message when it was processed and the error. So let's close this down. Then we're going to create my dynamic parameters, and in the end I'm going to format the actual SQL. So if I open this up, you can see that I have my update statement, then the values that I'm selecting as the dynamic parameters, and then we're going to execute this in one round trip to the database. So let me stop this and go back to release, and let's start this without debugging to check the performance of our update step. So let me expand this and zoom in. And after we initialize the Outbox messages table, we're going to go into the iterations of the Outbox processor. So I won't count the first iteration since it's a cold start, but now you can see that our update time has went to around 50 or 60 milliseconds per iteration, where previously I believe it was around 350 milliseconds, very similar to the published time. So we already managed to cut the processing time of one iteration in half. Now let's go ahead and remove the breaks, and by that I mean we're going to omit the delay in the Outbox background service, and let's start this and see how many messages we can process with the current optimizations in place. And after 1 minute the results are in, and we are able to process 152,000 messages in 1 minute, which is about double to where we were before making these optimizations. So we are definitely heading in the right direction. Now I've already squeezed most of what we can squeeze from the Outbox processor. I'm sure there are a few micro optimizations that I can make here, but the biggest limiting factor is going to be how long it takes us to publish a batch of messages. Now we're going to address this in just a moment, but another optimization that I want to explore is having multiple Outbox processors. This is going to give us parallel processing of our Outbox messages table. So how are we going to implement this? Well, I'm going to extract the processing of my Outbox into a separate method. So let's go ahead and create a private async method that I'm going to call process Outbox messages. The only argument I'll need is a cancellation token, and inside of it I'm just going to paste in what we already had. Now I'm going to update the linked cancellation token source to be my cancellation token, and then let's face the variables that I was using for logging. As you can see, I defined them here, but because I want to be running this in parallel, let's actually make them into fields. So I'm going to have a total iterations field that's going to start from 0, and then let's create a total processed messages that's also going to start from 0. I can omit these values here, and what I want to be logging is the total iterations and the total processed messages. And then inside of my function, I'm going to grab the iterations count variable, but we're going to get this using interlocked increment and I'm going to specify the total iterations. For the total process messages, I can do something similar. I'm going to say interlocked add, and then specify the total process messages, and then how much I want to increase it by, which is the process messages count. And by doing this, I can safely update these values even when I'm running this method in parallel from multiple threads. So this is just going to add some thread safety. And then for the actual parallel execution, let's go ahead and define one more field that's going to represent the maximum number of threads that I want to be running. And I could pull this value from my configuration, but let's just define that I want to run 5 threads concurrently. And then how do we actually run this in parallel? Well, .NET has some excellent abstractions for parallel processing. And I'm going to create an instance of the parallel options class, and here I want to set a few properties. One of those is the cancellation token for the threads that I want to run in parallel, and this is going to come from my linked cancellation token source. And then for the max degrees of parallelism, we have a variable that I'm going to set. Inside of my try statement, I want to say await parallel for each async, and then we need to pass in a collection that should represent the data that we're going to use to execute some actions in parallel. So I'm going to say enumerable range to define a collection of 5 elements, and we're going to use them to run some code in parallel. So this is going to be a delegate, which can be asynchronous, and the arguments are going to be the index and the cancellation token. And what I want to do here is just provide a delegate, and inside of it I'm going to await process outbox messages, pass in the cancellation token, and this is a very simple way of how I can run my Outbox processor in parallel. So let me go ahead and start this, and you should see that after I insert my initial batch of records into the Outbox messages table, the screen is going to go blazing because we will have 1, 2, 3, 4, 5 Outbox processors running in parallel, and you can see how they're executing in background and processing the messages. Now, the one limiting factor is you will see that the publish time has increased from 300 milliseconds, which is how long it took for the batch publish to execute with one Outbox processor, to around 1700 milliseconds with 5 Outbox processors running in parallel. Now I'm going to jump into when this completes, and you can see that we managed to process 165,000 messages using parallel execution. Now, this isn't all that much faster than when we were using just one Outbox processor. So what's the deal? Well, the problem is our bottleneck is the batch publish to RabbitMQ, and it pretty much increased by 5 times when we introduced additional Outbox processors. So this is a big limiting factor, and the solution is surprisingly simple, and you're going to be blown away by this. So what we can do is go into our mass transit setup, and when I'm configuring my host, I can pass in a delegate to configure some additional options. And one of those options is called configure batch publish. So what I can do is pass in a delegate to configure the batch publish options, and essentially the only value that I want to tweak is to set this to enabled. So what's going to happen is mass transit is going to turn on the RabbitMQ support for batch publish, and is going to internally buffer up to 100 messages before flushing the internal queue and publishing these messages in one round trip to RabbitMQ. I suggest just leaving the default values and setting enabled to true. Now, one thing that I omitted so far, and it's really important to make parallel processing work as expected, is that we're going to need to lock the rows when we select the Outbox messages for processing. So what you can do is just update this query to say for update skip locked, and what's going to happen is the batch of rows returned by this query is going to be locked from any other transactions, and if there is another query to fetch the same rows, it's going to skip the rows that are locked in some other transaction. And I actually should have mentioned this right as we introduced parallel processing, because without this, the results won't be correct. But let's check out what the performance is like when we introduce batch publish with mass transit, and also for update skip locked, which, as I said, is required for this to work correctly when we are using parallel processing. So let's start the Outbox processor and let's see what's going to happen. And as you can see, it's going completely crazy. The query time, from what I can see, is around 10 milliseconds. The publish time has now dropped from 1700 milliseconds to around 20-30 milliseconds per iteration, and then the update time is more or less consistent to what we previously had. So I'm going to wait for this to finish, and I can already see that we managed to process more than 1 million messages in 1 minute. So this should complete any moment now. And once everything is said and done, and with the correct optimizations in place, we managed to process 1,624,000 messages in 1 minute. If I go ahead and do the math and divide this by 60, we're going to get around 27,000 messages per second. So let's go ahead and multiply this by 86,400, which is the number of seconds in 1 day, and we get around 2,330,560,000. So this is the theoretical maximum number of messages that we could process in 1 day, which is more than 2 billion messages. And if you're working with this load, first of all, congratulations. And second of all, this is how you can process that many messages. Now here's one more thing that you can do, which is a bit risky, but when you are configuring the host, you can go ahead and set the publisher confirmation to false. And when this happens, mass transit won't wait for RabbitMQ to acknowledge that it has received a message. So if I go and start the benchmark one more time with publisher confirmation turned off, let's check out what performance we get after 1 minute. So with publisher confirmation turned off, I was able to process 1,926,000 messages. So almost 2 million messages in 1 minute. Now, is this worth it? Well, I'm going to leave you to be the judge of that. I personally would not turn this off, and I recommend using the default value with publisher confirmation turned on. If you want to scale this further, you're better off introducing additional Outbox processors than making your Outbox processing risky by turning off publisher confirmation. So let's just briefly recap what we did to attain this performance. We increased the batch size to 1,000. We optimized the query to utilize a proper index. We are publishing our messages in a batch, and we also turned off batch publishing on mass transit with RabbitMQ. We optimized the database update to use a batch update instead of updating one record at a time, and all of this gives us a significant performance boost by executing multiple instances of the Outbox processor in parallel using Parallel.ForEachAsync. If you want to deploy this in parallel, this could just be multiple worker services processing the Outbox all at the same time, and the key of how you're able to do this is using forUpdate skip locked. Now this is specific to Postgres. Other databases should also have support for this. At the very least, I'm certain that SQL Server also supports this using query hints. So there you have it. This is how we can scale the Outbox processing to handle more than 2 billion messages per day. And if you enjoyed this, make sure to smash the like button and let me know in the comments if I should do more videos like this one. If you are looking for more performance optimization videos, then you should watch this video next. Check out my courses to improve your software architecture skills, and until next time, stay awesome.